Right, hello everyone. Wishing you a great day. I'm connecting here from Taiwan. My name is Peter Knass. I'm a senior sales representative in Sensoneo. So I've been with the company for more than half a year, and working out my way through all the use cases that Sensoneo actually can cover by the sensors. You might surely know basic information about Sensoneo, so I wouldn't repeat them. I would just remind everyone that yes, we do have a hardware, we do have a software, and we do support waste management as our core business, which we have at the moment. You can see it in our logo: manage waste smarter. This webinar, I'm really really happy that you guys can join, and is not really targeted for waste only. So we have diversified ourselves to a level management solution where we will show you also use cases beyond the waste. Those use cases that can be supported by our software and also by our hardware, of course. So those use cases mostly in level management, and I would like to guide you through them and hope that you can get more inspiration of where the sensors can go, what kind of technology and what kind of placement in different spaces you can use. So mostly we'll talk a lot about containers. We'll talk about huge variety of containers. So hopefully it will be exciting for someone. Hopefully it wouldn't be too boring, and I will try to be really fast to guide you through different applications, so we do not take too much time today. So let me start. Okay, so I already explained to you that waste is 95+ percent of use cases which we do, and we are really focus on this vertical. We work with waste management companies, with collection companies, with municipalities to really make it perfect in every single sense, from every single point of view and use case, user, environment, etc., etc. But you can see a huge amount of space out there for deploying our sensors, and this is just kind of a summary. So we'll be talking today about waste use cases and also alternative use cases. I will guide you through every single category, and hopefully, if you have some questions you would like to ask, please feel free to put them into the chat of YouTube, and I will try to stop in between the waste use cases and alternative use cases to first reply some of the questions. And the same thing I will do in the end of the webinar. All right, so great use case to start. You have 500 portable toilets. Okay, everyone loves portable toilets. Everyone loves to attend some music festivals. You can imagine workers at the construction. They would be using portable toilets. It's nothing fancy, but it's a necessity. So you want to, especially in this situation of everyone being really careful about hygienical matters, you want to be really sure that those are not polluted, those are clean, and they are being cleaned up, regularly, and also based on the different level of the, I would call it, waste that you accumulated inside. So you can imagine this is a great use case, and I will have a separate slide on this, but you don't want to have people, cleaning team, just being there all the time. So you better use the software and get a notice if it's a festival, maybe every hour or like that, and send the people there to do the cleanup. So it's a great use case to start, and I believe everyone agrees with me that you don't want to get into the toilet which was not cleaned. But let's start with more traditional waste cases. indoor trash bins. We can see them everywhere, in the shopping malls, at the airports. We can see them, these size of trash bins, we can also see them in the office buildings, where the management companies, usually office management companies or maintenance companies, would be servicing these bins. They would have a team, maybe in the building, or in a group of buildings, which can be a multi-story. And there are hundreds of bins deployed. Specifically for the waste types, which includes recyclables, for example, you don't need to go there every single day to see whether the bin is full or not. You prefer to have it controlled by the sensor and get the information through the backend, to your either mobile phone, or it can be a backend system which Sensoneo is providing to you. So this is a traditional use case for indoor, different locations. We do offer two types of sensors. I would say would be a great fit for this. One would be a single sensor, and the other one, especially for the smaller bins, would be a single sensor split. What we call single sensor split is the sensor which would split the resonators from the rest of the electronics, just to make the part smaller and be able to place the resonators into the very tiny area, maybe somewhere in the top for those more narrower bins, or those we call it designer bins, and would not obstruct the hole for throwing the waste, and also would not be a big chunk of a sensor, in this kind of nicer designer bin. So we do offer this kind of solution as well, specifically for big shopping malls or airports, where you have a specific type of bins deployed. All right, when we get to street bins, this is more situation for municipalities. It can be situation for universities, for example, but also for national parks. Very important to have, very good control of those outdoor bins, because then the situation will happen just like in this picture here, where people, would not have any more space to put the rubbish inside, and they will just throw it, either put it on the bin or throw it next to the bin. Then the wind starts blowing and it's all over the park. We don't want our kids to be, playing in the playground where, you can see a lot of, the rubbish being blown there from the nearby garbage can. Another big, one is for beaches. It's a very good example to have on-time cleaning of those bins, especially in the very busy season. Usually, we use single sensor for these use cases. In case there is availability of certain low power network, meaning our sensors support Sigfox, LoRa, NB-IoT connectivity. We also do support Bluetooth mesh networks, so streaming over advertising over Bluetooth. That's also possible. So a single sensor can support all of these. If there is a country that does not yet develop low power networks, or the coverage is limited, we can still use GPRS, but that only with the Quattro sensor, which is a little bit bigger than single sensor itself. Okay, let's go to another case. All right, we get to regular residential collection, mostly nearby the apartment buildings, but also these kind of bins can be used, for collecting of some commercial waste. It can be general waste or different kind of recyclables. Advantage of our sensor is also that we can do a hardware type recognition of the pickup through the accelerometer, which is inside the sensor. We can not only recognize the pickup based on the tilt of the bin to the garbage truck, but we can also recognize it based on the lifting of the bin, meaning vertical recognition of the pickup. When there is a truck with a small crane to empty the bin, specifically it's for this kind of bins, which is like bell shape for glass, but also for some other types of the bins we will see later on. So this is also one of the examples of vertical pickup, where these are the semi-underground bins. You can find semi-underground bins in many countries in Europe, but they are slowly also spreading to other countries in APEC or US. They are semi-underground bins, meaning that they can be 3 to 4 meters deep. So they are only protruding around 1 to 1.5 meter above the ground. They're contained of the big kind of a cloth bag, which accumulates all the waste, and the pickup is based on the using a small crane into the garbage truck. So for these sensors, especially for those which are deeper, we use Quattro sensors, but they are also the ones that have a limited height, within like 2.5 meter in depth. Single sensor would be perfect for application of those. We have a very successful story and use cases of supporting semi-underground bins. They are especially useful in the very populated areas. So instead, you would have 7 or 10 different general waste bins and another 3 or 4 bins for glass. You can just deploy 2 or 3 semi-underground bins, which can solve you the capacity, and also does not cover so much of the space outdoors. So it's more kind of a nice looking solution also for nice greenery areas around the apartment buildings. Next category would be more into commercial waste. So we see these huge metal units, usually in the factories, or it can be in the big shopping malls or supermarkets, where they put all the general waste inside. These are the compactors, so they are compacting unit. The compacting unit would be pushing the waste towards the container area. So it will always go from the loading area towards the end, and would be pushed on the wall. So will be compacting all the time. Based on that, you also would like to see what's the level inside this kind of compactor bin, because obviously it's not that easy to recognize how full it is without having a sensor inside, or looking into the bin to make sure that it's full or not. So in this situation, Quattro sensor would be great, especially because of the many times the depth of the container maybe exceeds 2.5 or 3 meters. So it will be looking on the waste which will accumulate from this side, going backwards, being compacted. And in this situation, basically, you can recognize the level of the bin in this kind of application. Okay, next one. Everyone, time to time, would collect some used up batteries, or you would have your old phone, or you probably also have some electronics which you put into the shelf maybe 10 years ago and you haven't took it out yet, and you always consider it troublesome that where should I take them. So having Sensoneo system and having a public app, you can search where is the nearest e-waste collection point. It can be a collection facility, or it can be a drop-off bin, such like is on this particular picture. So you can input the batteries into this cavity, or you can put your bigger electronic waste into this area. So these are safe, e-waste containers. So even there is a fire from batteries, or there is a small explosion, they are really safe to be deployed. The pickup in this kind of cases is also vertical pickup, so they are being lifted, and you can have up to 2 sensors inside. Actually, we deployed single sensors. You can have a sensor to actually only control the cavity with batteries, and also have another sensor controlling the big container for the rest of the electro waste. Again, it's not being filled up every day. You don't want to have someone to go there and check the fill level every week or so. You can use our system. You can go very easily from bin to bin, or get notice when the bin is getting filled up, and then arrange the collection or arrange the contractor to actually go and execute the collection for you. So depending on the particular use cases of the business model that you would have arranged. The next one is a very good case, for this period. Everyone was staying at home, taking care of kids, and quarantining himself or working from home. But you probably also found some time to do a little bit of cleaning. Maybe someone not, but who did? Probably you cleaned up some of your old clothing and you don't know where to put them in. And the same situation as the e-waste, you can find the nearest clothing and shoe recycling container, and there is nothing better than to actually dispose responsibly, and probably there will be someone that can still use either the material or even the clothing that will be properly cleaned afterwards. This is a great example of the special kind of waste category that you can implement our sensors in and our system for. It's very valuable and a good for also charity organizations to use. Another one is very interesting, and is also giving kind of a social responsibility to people actually needed certain medical or have medical solved medical issues, such like you can have diabetes, or you need to use needles to inject some medicine. Or we also have the category of people using drugs, which would be not that responsible in disposing the needles, in order to make sure that everyone dispose needles safely, or any kind of sharps. So it's not only needle box, any kind of sharps. They can input it to this needle drop box, and it can be safely disposed. You would not find these on the grass somewhere in the park, or nearby bus stations or bus stops, where everyone knows that this is happening in every day, especially in some more populated areas. Okay, we go to another category which is very closely connected with the commercial waste, and it's a special category for actually measuring already waste liquid. So this one particularly used in US for measurement of basically used oil nearby the restaurants. So this is very typical case. You can imagine, fast food restaurants like KFC, McDonald's, Taco Bell, etc., that would be frying things regularly. They really need to, do the disposal of used up oil very responsibly. So there is a special container for that, and you can implement a single sensor on, let's say, NB-IoT network, and do collect the excess oil and irregularly, based on the demand, do the pickup. In this case, and also in some other previous cases, we have found our applications our sensors being enclosed in the metal bins, meaning that the signal is really weak in the metal bin, because the metal bin actually works just like a Faraday cage for signals to go out. For those use cases, we actually do have an option to implement external antenna. Many of our competitors, they don't have this option at all, but we found it necessary for a good connection and good signal reception to use external antenna in those cases where they are really enclosed containers inside, and there'll be more of them as we go through this presentation. Another one, which is also interesting and is very closely related to sharps, is also disposal of prescription and recreational drugs. So you go to the airport. You need to get on the plane. You cannot take your prescription drugs to the country where you're going just because of the law. Instead of throwing it into regular garbage, you throw it into this kind of special purpose bin that is very very responsible management of dropping this kind of item. So then also the processing of this kind of items is done properly based on certain medical standards. Okay, so we are through one part, which is waste use cases, and I hope that you got some nice insights from it. So I will just jump to see whether there are any questions. All right, I don't see any questions as yet. Maybe we can take 2 minutes for a short break. So that in case someone has a question, I would wait here. If not, I will then move to the next section after those 2 minutes. All right, so thank you for no questions. That makes my life slightly easier, although I encourage you to ask more questions, or if you don't come out with the questions at the moment, you can always contact your sales representative in Sensoneo, or drop me an email, which would be available in the end of this presentation. I believe while I was resting here and getting my cup of tea, you already went through the slide with alternative use cases, so I wouldn't go through it, but I just directly jump on the first one. All right, secure document shredding containers. This is a very interesting use case, especially in business-to-business field. There are multiple companies that would support shredding services of very confidential documentation. You can imagine it can be a bank, it can be a big company, it can be a ministry, or department, state department that is dealing with this kind of confidential documentation. We had particular case with a bank where this was essential to them, because you are having this confidential document disposal bin in the public area where your employees are working, and you don't want to have a guy coming in, opening it with a key and looking how full it is, because in generally you don't want anyone to open it before the documents are really shredded. One of the solutions is really to work out to mount the single sensor inside the bin, and if needed, use an external antenna if the signal is insufficient inside. And this way, you maintain the confidentiality. You don't need anyone opening or looking through the small hole how full the actual bin is, and then just call the shredding services to take care of the shredding once you reach a certain threshold, let's say 80% or 90% fill level of the bin. So this is a very good case, and I believe you guys, as usually attending, would be partners of Sensoneo, pushing our solution to some concrete applications. This would be a great case if you talk to some maybe municipalities, banks, or state departments. Right, go to the next one. We have a lot of green green policies and new green waves in our daily life, which are connected to a kind of sustainable future. And one of them would be certain clothing stores or clothing brands that would like to show you how they are involved in safety disposing of clothing or recycling, etc., etc. So it's usually it's part of their PR activities, but they would put bins to collect the clothing inside their stores. Just to give you opportunity to really dispose your old clothing inside there. Then they really consciously process the extra clothing, and they would have a great PR on this. So if you have connections to any kind of brands like these, they would be interested to work out this kind of application. We do have sensors for the bins. You don't want the staff of the supermarket to be actually managing these bins, because they have other job to do. But you can have a person in certain region that would be actually collecting these excess clothing from different stores for you, based on the requirement of the system. Right, next one. And the one after this would all talk about levels in water tanks or similar kind of containers. Especially it's worth to use this kind of technology when you are in some remote farming area, or you deploy multiple water tanks across your farm, or in certain villages as well. So measurement of the amount of water left in the water tank is essential for someone's life, or is essential for farmers to grow crops. So it's good to not underestimate, the efforts in kind of digitalization of the actual bin, putting sensors inside, and having this container properly monitored. Particularly those huge ones which we can see in the farming areas. The second one is kind of like also it would be opposite one, but it's also related to collection of the water. The first thing why we monitor the level of the water in the retention tanks, rainwater retention tanks. So you can imagine this application basically collect water from different roofs or from big roofing area to prevent actually accumulating on the pathway or flooding the road, and also in the drier countries to collect the rainwater and then use this rainwater for watering plants or different kind of purposes. So from the first point of view, you want to monitor the level of water inside the retention tank, just to make sure it does not get too full. Otherwise, you again causing flooding of the road or flooding of the pathway. And from the second point of view, you want to accumulate that water, and you want to make sure how much water is left there, so you can manage your watering and your other water collection purposes really well. So having a single sensor inside would be great for this kind of application. I can remind everyone that our sensors are fully waterproof. So we do have IP67 tested sensor, and also we have pre-tested IP69 for very high pressure washers. This certification is yet to be finished, probably in very early period, but our sensor is performing really well in terms of waterproofing. So it's really suitable for the applications like this. Second one here, and a very interesting case, would be book returns. Every city or every university would have a library. Every time you return the book, they don't actually, they try to eliminate the person-to-person collection so that the librarian or the people working there are more taking care of other stuff. So they would implement these kind of book boxes or book bins for book returns. What's happening often is that these book returns containers are getting full very easily, especially in some after the exam period, when students would be returning books, or after the closing to the end of the school year, and once these boxes get full, people will be just pushing the books inside and trying to push other books to get more far, so they can still input their book. But that creates damage to the book, which is not very good, because you can imagine that your pages would get destroyed or even teared off. So which is very I would say it's not very disciplined to do such. And that in such cases, people will start piling the books on top of the box, which is not very good, especially if it's outdoors. So there is nothing better than having a sensor to tell you, or to tell the librarian that, okay, your book returns bin is full. Please go to service it. And that's very easy to do. It's a very nice application. Library probably would not have to do a significant investment to have this kind of application done, and it's another use case, to have the sensor on the map and used by someone who can actually make a very good use of it. And now we are getting to another category, which would be more huge kind of container monitoring. So here, particularly, we would have a shipping containers. While you can imagine the huge shipping docks or even the companies managing the containers, they would like to have also a digital footprint behind the containers, knowing whether there is something inside or not, or whether there was something, maybe they mistakenly would move certain container in the dock, and so on and so on. So actually having such an application and such a use case for having a sensor inside would be commercially beneficial to these kind of companies, especially in some container yards where they are daily coming in and going out, maybe tens or hundreds of containers. So having those containers monitored would be actually valuable also for the shipping companies. So if you would have a contact to this kind of industry, we would be happy also to work with them to implement our sensor inside. It can be either single quattro sensor, so only one quattro sensor inside, looking into the space maybe in a wider angle. But in order to get a really more precise overview of whether there is something inside or how much of it is inside, you can actually deploy two sensors on each side. As I said, for someone it's enough if they know if there is something inside or not. So in those cases is also very valuable. So usually the level of the fill of the container is not that necessary in this kind of application, rather than to recognize which one is empty and which one is full. The same kind of situation is with trucks. So if you want to monitor your cargo, so let's say you are a big commercial company selling a lot of commercial goods, so you have your own transport fleet and or own transport loaders. You would like to make sure that when the truck is moving, whether there is something inside or not. And this is very important because you want to make sure that you maximize the efficiency of your trucks, and you want to make sure that there is a cargo if there's supposed to be a cargo, and that there is no cargo when there is not supposed to be a cargo. So there were cases, especially in Europe, where when the driver was transporting some cargo without having his management company knowing that and earning under-table money. So those kind of companies also can make use of this kind of technology to see whether there is a cargo inside or not. So usually quattro sensor would be the best for that. If there is no sufficient signal inside the container, we do recommend to use external antenna for better signal reception. Especially we are talking about a truck which would be moving, so the cargo would be moving as well. So we can use external antenna just to make sure that even with the signal, with the low signal coverage areas, you can still get very nice data readings as well. So this is a nice application as well. We have this kind of case in Europe. Another one, and that's completely different than what we have talked about, is actually measurement of level of the laundry baskets. So in big hotels, they used to have a big laundry rooms where they are shooting the laundry into the chutes. The chutes will be directed to the certain container, and that container can be monitored. It can be monitored from the chute downwards. So the sensor would be installed on the chute here and would be looking inside the container. Then once the container is filled up, the worker would be notified and he can switch the container for the empty one. It also works really well for the companies that actually do laundry professionally. So they would be kind of an outsourcing company for multiple hotels or multiple commercial areas where the laundry needs to be done, like restaurants, for example, and so on. Okay. Then we have our portable toilets. So we spoke already about these. So I wouldn't spend too much time. As I said, I really would like to stress that this is very actual and very good application. And in these times of more, everyone is being more careful about hygiene, and especially with the business ramping up, construction continuing, people would like to be sure that the service at these kind of areas, such as toilets, is really done properly, and it's really clean there. So having the portable toilet being cleaned up is a basic requirement, even for the or especially for the construction workers, that actually is a necessity for them on the construction site. Apart from having a sensor or the level recognition, we also understand that these are portable. So you can always make use of GPS in our Quattro sensor, so that it can detect where your portable toilet actually is deployed in particular week, or if you have a special case, we can also try to set up the GPS fix to more often. But that would also depend on our discussion about the battery life. So yeah, this is a very good use case, and we go to the next one. And that's a very similar one. So septic tanks. So it's similar use case, but on the fixed area. So I wonder how many of you would have a septic tanks besides your house. Mostly in the remote villages area, it's a very regular solution. And for big cities, of course, there is a canalization system which can solve this problem. But if you have a septic tank, and you are not a huge techie, you would welcome an option to have it monitored, because you don't want to open it, you don't want to look inside. If there is a service that can provide you a sensor that can provide you readings, and you can see it on your mobile phone through the app, there is nothing more convenient than that. So we also can work in this kind of application. Of course, in this case, the septic tank is made of concrete. The amount of signal inside would need to be measured or checked, but for being actually very precise, you can still use external antenna to make sure that you got that coverage that you need in that particular area. Okay, and that's another very interesting use case, and it's actually touching every one of us, because time to time we still need to use POS. Although I would say 99, or at least in my case, 99% of documentation is now being digital, meaning that using of the POS box is not as regular as it used to be. You can imagine that the post office still works on their own old, very inefficient collection way, where the postman always needs to go to the post box and see whether there is a single letter or not every single day. That's very inefficient, considering the post is a huge organization. They have huge fleet of vehicles, motorbikes, etc. But they are always in negative numbers, just because of their huge operating costs on this logistics mostly. So there was an idea of having a sensor in the post box to detect whether there is a single letter or not. And we are thinking whether our sensor can do it or not. It's very tricky, because you are not actually monitoring very big chunk of material, but even a single letter, which can drop on the bottom of the bin. In these cases, our engineering worked very smartly, and they came out with a solution for this, where basically we put audio foam on the bottom of the pulse box, which creates a longer distance reading from the actual level sensor. So the sensitivity of the sensor is actually increased even you drop a single letter into the pulse box. So it's very smart way of dealing with such a situation. And so once you throw a letter inside, you jump directly to, let's say, 25 or 30% of your field level. You know that there is something, and that's enough, because you even need to pick up a single letter. You don't need to pick up when it's half full, because then maybe in some remote areas you can wait for half a month till it will be half full. So you need to service every single customer you would have. So in these kind of cases, having our sensor with this kind of setup is really helpful for operating costs of the post office. Having the post boxes of different materials, again, I would remind that the coverage on certain networks need to be verified. If necessary, there can be an external antenna mounted on the top or on the side of the box, connected to the sensor, just to have very good readings. And we are coming almost to the end of the presentation, and this is kind of a top notch of our engineering, where we develop waste sensors for very small containers, and moving to bigger ones up to the silos. So silos can be up to 9 meters deep, or 7 meters deep. There can be of different materials, and they can also input different materials inside. So it can be functioning as a water or liquid tank for certain chemicals as well. It can be a dry chemical. It can be also crops, silos with crops. It can be silos with salt for the road maintenance, for example. So there are various applications of silos, and they are all over different applications, different regions. So it can be industrial, it can be farming, it can be road maintenance. They are everywhere, and I believe you already pop up in your mind with some use cases where you think that, okay, these guys might be interested. And we found the same thing. By modifying slightly firmware of our Quattro sensor, we are actually able to extend our reading from maximum of 4.5 meters up to 9 meters, which is like double the reading distance compared to our original. Of course, this kind of sensor needs to be specifically updated with the firmware that actually is capable of doing this. But it's a great application and opportunity for everyone of you to push to certain market verticals where they would use this kind of bigger containers, or I would say silos in this case. All right, so we are at the end of this presentation. So hope it brought a little bit a new view of on the level sensors, and where actually can be different business or use cases, and it would help us to find more opportunities together to enlarge our coverage and enlarge our participation on the world market with sensors particularly. So it's not only software. The software can support everything. It's very flexible. But we can see that hardware is not limited to a certain type of container, and is not limited to a certain type of environment. So I would be very happy if I can reply your questions. Also, if I can hear your feedback, and also if you have some other use cases which we haven't covered here, we would be more than happy to know them. Call us. Let us know that this is the way that we can also deploy our sensoring, and we will be happy to input it to our portfolio of applications. So I will, what I do, I just come back to the questions and see whether there are any questions. Okay, so we have a question from, sorry if I pronounce it wrongly, Øyvind Martinsen, have you actually implemented in all these applications? So that's the first one. Most of the applications we did implement it, or we did do a research or testing. So we have clients all over the world in different applications. They come out with different ideas. Then they usually purchase a starter kit and they do kind of a testing, and some time to time we do the testing ourselves in our office. So yes, most of the cases we have implemented. Although I can tell the truth that, for example, a concept about containers, it was not actually implemented in the real life as yet. But most of the cases we did went through. The second question, which I see here, in silos there is a lot of dust, like from grain crops. How do you solve this dust covering the sensor eyes? Okay, so our there is a still something that we need to clarify about the sensors. So we use ultrasonic sensors. So ultrasonic sensor is not optical sensor. So optical sensor, once it's covered with dust, once the visibility from the optical sensor is really bad, in those cases the measurements are distorted right away, and you have very bad numbers, and you would realize that okay, you need to go there and wipe the optical sensor, because it's really dependent on that I would say view from that lens. In our sensors are ultrasonic sensors. So ultrasonic sensor, as you say, it's not working on the principle of eye. It's working on principle of ultrasonic resonance or ultrasonic sound, which is shooted from the ultrasonic sensor downwards, and then the receiving sensor is waiting or is for the reflection coming back. So that's the difference between the optical sensor and the ultrasonic sensor. Although I'm not able to tell you that okay, if the sensor is totally covered in dust, there would not be a potential probability that this certain distortion would happen. But we see it very rarely, especially when the sensor is looking downwards, so the dust is not piling on the top of the sensor. All right, so next question is from Ms. Jelena Stojanovic. Thank you. Are you complied with ATEX for sensors for silos? So ATEX is for the exploding environment. So exploding environment is mostly for the containers where there is certain chemical accumulated and possible of blowing up. So especially for gas, or for regular petrol. For example, for diesel, there is not the case, because diesel tank is diesel is flammable, but it's not explosive. At the moment, we do have after the COVID-19 restrictions release, we already have booked. We have booked actually a testing lab that can test to ATEX certification. So we have that in mind. Not for silos though. We have that in mind for more like gas tanks or petrol tanks, where we are required by companies like, I would say, Aramco or big petrol harvesters to be compliant with this kind of certification. So for regular silos, like that would have crops or some non-explosive chemicals, yes, we do comply now. Although for the next level, or maybe in 1 or 2 months later, you would be able to hear from Sensoneo that yes, our single sensor complies with ATEX certification. So it's built, very reliably. We just need to have that properly tested by third-party lab. And Øyvind Martinsen also mentioned that a layer of dust will still mess up the reading, regardless of it being optical or ultrasonic. I agree with you, yeah, and that's what I say. Like we do try to, our sensor is looking downwards. So of course, having the piling of the dust on the sensor would be still distorting it. It's from the physics, everyone knows it. But I would say ultrasonic sensor is dealing with this kind of situation much better than the optical sensor. If you want to go to the next level of solution, we would need to implement a radar or a different kind of technology, which so far, it's coming slowly. So far, it's a little bit more expensive than will be ultrasonic. But, we are looking at those technologies, and, we'll give you updates once we can solve these kind of issues. Okay, I'm looking at more things here. So we have, from Elena again, in case of dust material in silos such as food for the pigs or similar. Yeah, for those applications, as I said, that would be great if you have such application. We can do a testing, and we can actually, I believe that we can comply with all the requirements needed, and our sensor would be performing well. So please just contact the person that's responsible for your market, or drop me an email, and we can talk about this in detail. Same for Oybin. Thanks a lot for your input, and we will, if you bring the case in detail, it will be great, and we can explore it together and find a solution. Also, if there is a problem in this case, we'll be happy to make sure we can solve it. Okay, Mr. Jules Aiden, has Sensoneo considered using the sensors in the shipping industry to monitor the ingress of water in dry holds of cargo ships? Okay, very interesting. And we have not considered it yet because we had no such reach so far. So if you would have such case, we would be happy to explore it together with you. I believe that if we can see what's the concept in detail, and what would be the environment there, we can make this work for you. So please just let us know more in detail about the application. I will be happy to support you. Okay. Okay, seen a sensor that vibrates every X hours to shake off the dust. Looked like a clever way of solving it. Yeah, thank you for input. I believe someone from our technical guys also on this call, and we are also recording it. So we'll definitely take this input, as a possible way of solving such an issue. All right, so I don't see any other questions here. We spent, I think, exactly 1 hour to go through this presentation. I hope it was not too long, and it was not too short for you. And I hope that Sensoneo can bring you more these kind of short webinars and updates about what we have. Even it would be 20 minutes or half an hour. We like to push some more information to you. To find more, applications or more opportunities in business. So thank you very much. I'm really happy that so many people participated, and I'm looking forward to do this again, and hopefully I will get same big audience. Yeah, thanks a lot, and have a great day.